We are live, blast off. Hello, good afternoon and welcome to Space to Learn. I'm Adam Gendel. Thank you for joining me on this gorgeous Tuesday afternoon. Today, we are going to be joined by British-born space hero, Dr. Mike Foale, CBE. Mike is in the NASA Hall of Fame. He's flown 6 space missions. He's spent months on the Mir and International Space Station. He's completed multiple spacewalks and helped save a space station and its crew from peril. Oh yeah, he is a real life space hero. He's also very good with the Rubik's Cube. Look, he's really clever, basically. So if you've got any questions for Mike, please send them over using our Twitter. Let me get that little information up there. Hang on, there we go. Use our Twitter at ISSET_STEM. Use the hashtag Space to Learn. You can also put them in the comments in YouTube if you've got any. We'll try and get through the best questions that suit our topic today, which is the thrill of doing things for the first time. So maybe you want to ask him about the first time he sat in a rocket, the first time he did a spacewalk, the first time he had a space sandwich. I don't know. It's up to you. Mom and Dad, save your questions for our grown-up program, however. That is Space Talking with an Astronaut, which goes live every Thursday at 7 p.m. UK time. This week, we're going to be joined by Greg Johnson, but you can check out all the details for that on ISSET.org. So let's get over to Mike for today. Mike, are you there, my friend?
Yes, I am. I hope you can see me.
We can see you, dude. Where are you? No, I can't see you yet. Where are you?
I'm waving from space.
There you are. All right. I've got you. I've got you. As ever.
That's the International Space Station behind me there, Gendel.
Nice. I like this spot. I was saying it's a lovely composition with you in the Earth's curve there, and it's gorgeous. How are you today, man? How's Colorado?
Yes, I am in Colorado. That's in the United States. For those of you that are weak on geography, it's in the middle of the United States. We are also in COVID lockdown, but I'm in a county with very, very few people who live here because I'm up high in the mountains. And so not many of us have been infected here, only 2 people out of the 770 that live in the county.
So you're staying safe, you're staying home, and you're being good, yeah, Mike?
Very good. That's what my mum would think.
All right, good man, good man. All right, well, we're going to do the Q&A, as I said, a little bit later on. But before that, have you got a video or something to show us?
I think we do, because we prepared for this.
You did your homework, didn't you, Mike?
I did my homework, yeah. So let's just cue it up. I'm going to I have to share the screen, don't I? Right?
Yep. Share your screen. Hit your video.
Get my video up. So you're going to share the screen. And then you can see me click it and make it go.
This is always my favorite bit.
Yeah, if it works or not.
Tension building of whether it's going to work or not.
Share the computer sound and all
there
that
you
stuff.
go.
And then you should start to see stuff now.
Look at that.
No, it's still not happening.
We've got you. I've got the young picture. There you are.
That is me. You won't believe it, but let's get something straight right now. I am 63 years old, girls and boys. I was born in 1957. You're seeing pictures of me when I was younger. This is on my first space flight in 1992. I was already 35 years old then. I'd wanted to be an astronaut since I was 6 years old. Here I am driving a tank around outside of the space shuttle. That was in case we had to run away from the space shuttle if it was going to blow up. You're seeing here pictures of me again in the earlier parts of my career. I was an astronaut for 27 years. I was born in England, had an American mum. That's why the American flag's on my shoulder. I had a British dad, Royal Air Force. I was the youngest person out of 15 new astronauts selected in 1987. And I was one of three scientists in that group, of mostly military men. Not many women in that group at the time. This is me on my getting ready to go out to the space shuttle for my very first launch. I'm very excited. People said I had a kind of a surfer boy haircut in those days. I loved windsurfing. I lived by the bay in Houston, Texas, and would windsurf as my spare time. I've always liked doing outdoor things, different outdoor things, but and of course, being in a space shuttle being launched for the first time, that was new. I was doing something new, but it wasn't outdoors. It was on the flight deck of the space shuttle being shaken around pretty violently left and right. being blasted off into space. I was what they call in America a rookie astronaut, and a first timer. Here I am now on my second flight into space on STS-56. STS means Space Transportation System. That's what they called the shuttle in those days. And I'm being launched just a year later after my first flight. This is my second flight. Now, Ellen Ochoa is my colleague scientist on this mission. I'm flying as a scientist on both of these missions. We're studying the atmosphere, the Earth's interaction with the sun, global warming. Yes, we knew about it in those days, and other things like ozone over the Antarctica. We launched at night on that second mission. On my third mission, I got to do my first spacewalk, and I was incredibly keen to do this spacewalk. It was moving a big box around that weighed about 1.5 tons. We had to hang on the wall. And looking at my colleague, first African-American ever to do a spacewalk was Bernard Harris. And he was my colleague, my mate, my space mate in space. And we were blasted off to do a test of the spacesuits to see how cold we would get and to move that gold satellite around called Spartan. It was an astronomy satellite. During that mission, we'd visited the space station Mir, a Russian space station that's not in space anymore, but had been there for 13 years spying on the West and doing Russian science experiments. And I was sent as kind of a guest astronaut, but I was there during a collision. It wasn't my fault, but the Russians tried to cut costs, and it ended up with being a big bad collision with a space cargo ship called Progress. And I was on that Russian space station speaking Russian for the first time in my life for about 4 months. On my 5th space shuttle flight, I was launched to go and repair the Hubble Space Telescope. Not just me, it's 7 of us, and there's 2 teams of 2 spacewalkers, and I was to go out in a spacesuit. And I'm going to be telling you a lot more about this mission later on, but we had to repair the Hubble Telescope. The Hubble Telescope is really big. It's as big as a school bus. And my job was to go out with Claude Nicollier, a European astronaut who was an astronomer. That was a galaxy a nebula we just looked at there. And then this is my 6th space flight, being blasted off in the Soyuz. It's a Russian rocket, originally designed to throw atom bombs at us. But now it carries people. Yuri Gagarin was the first person launched on it, and I got launched on it much, much later in 2003. Here I am on the International Space Station. That's the space station that's in space now. I did a lot of speaking from space about the Earth. I did spacewalks. I was commander of the ISS, that's what we call it, on my last flight, mission number 6. And I was on the ISS for 6 months, 195 days, although I wasn't counting. These are various shots from my different crews going back in time now, looking younger and younger, and more hair. And those are the patches, the emblems that we had for our missions. So I think I go back to
unshare. We'll stop sharing, and then we'll get some questions.
Yeah, we get some questions in.
That was pretty. You do look like. Have you ever seen, Tony Hawk, the skateboarder Tony Hawk? I think you looked like him when you were young.
Is he a cool guy?
Of course he's cool. Yeah, he's amazing skateboarder. The kids all know anyway. Incredible stuff, man. That is unbelievable. So, yeah, you've had quite an incredible career. Just to start us off, I mean, there'll be a lot of kids in the UK watching, because obviously you can tell by your accent, a UK based, even though a lot of people, when they think of astronauts, they think of American and NASA. What did you do when you were a kid? Well, I know you're a bit of both, but what would you say to kids in the UK? What subjects should they be studying hard at?
Really anything kind of sciencey. I do think artists and actors and maybe, anybody really who's TV presenters like yourself, Gendel, they certainly could have a career in space, but to be paid well, consistently and have a salary, I would recommend going the government route. And the government route means you get selected to be an astronaut, a bit like joining the military or becoming a pilot or joining the army or the Navy. And so you go through selection, and to pass the selection, you need to study a science subject, something like, in my case, physics. I love physics. I'm going to tell you a lot about physics today, I hope. Chemistry, maths, obviously, is an important thing, and biology. So those science subjects are important to be qualified, and you have to go to university. So to be a government astronaut, you have to go to university, get a degree, and they prefer, the selection committee, for you to have a graduate degree. That means spending 6 years at uni, maybe even 7 or 8. So it's a long time. And so by the time you're actually ready to be an astronaut and be flown in space, you're already over 30 years old, which to a lot of the kids watching today is as old as their granddad.
Yeah, it comes around fast though, doesn't it? 30 flies up. All right, well, I kind of snuck that question in there. I went off topic because we do always start with the same question every week, which I should have started with, really. Why did you want to become an astronaut when you were a kid?
I think it was a good question that my mum asked me when I was about 6 years old. She said, we were visiting a museum and there was a spaceship that flew John Glenn, the first American to orbit the Earth, going around the Earth. That's an orbit we're seeing behind me there of the space station. And they said, what do you want to be when you grow up? And I don't know, Thomas the Tank Engine flashed into my mind, and airplane pilot, because my dad was a Royal Air Force pilot. But they said, well, how about being an astronaut? And this spaceship in front of me looked pretty blackened and looked like a burned up dustbin. So I didn't think too much of that idea. But above us was a space shuttle model. And I said, how about that? And they said, yeah, that's a space shuttle. I said, well, maybe I'll fly in that. So that was the first time they made me think of being an astronaut. So then they gave me books on astronomy. And I think you'll see later on in this talk today how astronomy really turned me on to space, really got me interested in space.
Okay. All right. Well, we'll get onto that in a little bit. Okay, let's get to some questions from our viewers. Hector asks, what did it feel like entering space for the first time?
It's a bit scary for the first few minutes, because actually I was selected after the Challenger accident. It was a space shuttle that blew up during launch, carrying a teacher into space. It was a very sad event. And I'd watched that on TV. I was working at NASA. And then I was selected right after that, a year later. And of course, while I was on the launch pad and in the space shuttle, I was thinking about how astronauts had blown up. And so I was nervous, a little bit of adrenaline in my tummy. But once the engines stopped, and that's what we would consider entering space, we're not being pushed down like this hard at 3 or 4 Gs. Instead, your hands kind of fly up like this, and they're kind of floating. And that's because they're weightless. Your hands are weightless and they just lift up naturally. And that made it, I realized, we cheated death. That's what I said. I said to Brian Duffy, who was the pilot in front of me, I clapped him on the back because I was sitting behind him on the flight deck. And I said, Brian, we cheated death. Anyway, I cheated death 6 times at least.
Well done. Good work.
Anyway, it was a great feeling of relief. That's the answer. And then, of course, you're dealing with weightlessness for more than 20 seconds. That's what I'd thought in airplanes up to that point. And the weightlessness, of course, your helmet has to come off and it's floating away, and your pencil floats away, and you're still strapped in your seat. So it's all a bit embarrassing because you're clumsy and you move your hands too fast and you knock your helmet and it bumps someone, and you're worried about it touching switches and activating the switches. So you suddenly go into massive be careful mode. And then the next big thing after the weightlessness and managing your helmet is to go and look out the window. And that's brilliant.
That's your treat when you first get up there. I bet it's kind of weird, your brain just registering it experienced something that you've never really, other than the flights that you've tried, but that weightlessness is so different in your brain, isn't it? I guess so new.
Yeah, well, it is. Gendel, you got it.
Okay. Right. Anna says, why are there more boy astronauts?
Oh.
She's aged 5, so maybe she wants to be an astronaut herself.
Or a mum asked her to ask that question.
Maybe.
But no, Anna, now I'm glad to say, if you took a picture of all the new, you saw a picture in that video of me with those other 14 astronauts looking pretty old, I mean, retro. There we only had 2 women in my class of 15. One was the first African-American woman to fly in space, Dr. Mae Jemison. She was a medical doctor. And the other one was Dr. Jan Davis. She was a scientist that could do material science experiments and things like that. Now, if you looked at the picture, there would be 50% women. So it wasn't as good for women then to fly in space, but now the opportunities are equal.
Yeah.
And NASA, every girl should listen to this, and the guys just have to be quiet. NASA has committed to launching the first woman to land on the moon. And it's part of the program called Artemis. And she was a goddess of, I think, the moon, actually. So anyway, like Apollo was the moon landing program for men, Artemis will be the moon landing program for women. That's not to say that men won't fly, but I think the next woman, the next person, the next human to land on the moon will be a woman.
And when's Artemis planned for?
Well, they were hoping it was going to be 2024, but I think, you know, if you're a 5-year-old now, by the time you finish uni, it should be happening.
Yeah. Hey, you never know then, Anna. Could be you. Okay. Charlie, age 7. How do planets get their color?
Oh, very good question. I like it. So right behind Gandil, you see some colors. I'm not sure what they are, but they're caused by light having different color. Light has different colors, and if you've ever looked through a prism, that's a piece of glass that changes the light, the white light that comes from the sun, into colors like a rainbow. The same effect happens with planets, and planets' atmospheres behave like prisms somewhat, and so they do a thing called refract. That's with an F, refract the light. And that's why they have different colors. Also, the surface of Mars, for example, is rusty red. And that's because it's got iron, lots of iron that's rusted, and rust is reddy brown. It's got lots of that on its surface. And so that color shines through the atmosphere of Mars, which is very thin. So the atmosphere doesn't have much color, but the surface does. So that makes the color of Mars. Venus looks really white. By the way, if you go outside right now, and you see, Venus is the brightest object in the sky other than the sun. Venus, all its color is mostly reflected and refracted light from the sun. So it's white looking with little bits of yellow. So it all depends on how much atmosphere and how much surface.
Okay. Which is your favorite planet to look at color wise?
Color wise, I'd say Mars, because it's red. You know, I like red. I think red. Now, my favorite planet look at from space is the Earth.
Yeah, definitely. People always ask me what my favorite planet is, and I always say I'm gravitating towards Earth.
Very funny. Yes, actually, with luck, you're in orbit around Earth and won't smack it.
You can have that joke if you want. How did you know what time it is when you first go into space? That's from Adam Day, aged 8.
Hey, Adam, we always have watches, and NASA gives you a watch that they take back from you because they don't ever let you keep anything. So I bought myself a watch. It's a Casio. I don't know.
We can't see it. We can't see it. Go back a bit. There you go.
It's a Casio, yeah.
Yeah.
Anyway, it measures pressure, which is important if you're going to be in a space station that gets hit by a progress and loses its atmosphere. That happened to me once. So it measures pressure and tells me how much the atmosphere is there in the space station or the Mir. But also, we use GMT time. We use British time. We don't use summertime, which you're on right now. We use GMT.
Oh, so everyone on the space station uses that time?
Correct. Yes. Yeah.
Oh, right.
So the Russians, who are in a time zone ahead of Britain, 3 hours, they're ahead of space station astronaut time. And the people in Houston who are operating the space station in America, in Texas, they're actually 6 hours behind. And then people in like Belgium and Germany, where the European Space Agency Control Center is, they're an hour ahead of British time. So it's everyone's living on a different clock.
Okay.
We all live by the same clock, GMT.
Okay. All right. Leo Elgin in Scotland, age 7, says, how does a spacesuit and helmet work?
Well, the most important thing for a spacesuit is to keep the air in. So, you know, behind me, that beautiful view of the Earth and that black space, it's black. There's no stars there because the sun's so bright and the camera can't pick out the stars. Same as our eyes, we can't see the stars on the daylight side of the Earth. There's no air there, right? So we couldn't breathe. And so the spacesuit and the helmet, they all hold the oxygen in. And we actually, both Russians and Americans, and maybe European spacesuit too soon, they all use pure oxygen. It's just, if we have pure oxygen, we don't need to put nitrogen in it. And that keeps the pressure lower in the spacesuit. And it means the spacesuit will be more flexible if we keep the pressure low. You know how a balloon gets stiff when you blow it up? Or a tire, you know, or on a bicycle. Yeah. And you're using your gloves and things, it's really hard to move against that stiffness. So if you keep the pressure lower in a spacesuit, you have less stiffness to fight against, because you get very tired working in a spacesuit after some time. Yeah,
I bet. All right, well, shall we maybe check out another video? What else can we have a look at?
I'm going to show you a little bit about the Hubble Space Telescope. And we'll go, I don't want to go full screen yet. I've got to go zooming first. Everybody, I had to learn Zoom, trying new things. That's the gist of this topic, right?
See, this is good for the kids to get. The kids can start practicing doing Zoom chats, and because if they can conquer that,
tricks,
then they can be an astronaut. I think, because it's almost as complicated.
Right. So I'm sharing the screen, right? You see that?
Yeah, we got it. Got your PowerPoint up there.
Let's see what happens now. Does it go?
It needs to go full screen. There we go. Perfect. What are we looking at?
Is a picture looking out of the car. That's on my 5th space shuttle flight. That bright object in the top left is the sun, and the gold foil is covering parts of the spare boxes we're going to put into the Hubble Space Telescope. The Hubble Telescope isn't there yet. And in the right-hand side of the picture is the space shuttle arm. Now, this is my last space shuttle mission. It wasn't my last mission, the last space shuttle one, where we repaired the Hubble Telescope. This telescope is as big as a bus, school bus, and weighs 30 tons. And it has gyroscopes in it, 6 of them, 3 of which are needed to make the telescope point and stay pointing at a star or a galaxy or lots of galaxies at the beginning of the universe. And when we were launched in the year 1999, there were not the gyroscopes in here, 6 of them, 4 of them had failed. So we only had 2 working that were left. And they'd failed over 2 or 3 years. So they weren't really bad gyroscopes, but they didn't last long enough. And we've been launched to replace those gyroscopes. My job, though, was also to replace a computer up here on the side, change it into a computer about as good as what's in your phone today. So that's
what is the main use of the Hubble? What's the primary use of the Hubble
the Hubble is a telescope, so it looks at galaxies, stars, and it tells us all about the universe and where it came from.
So it's mainly for shooting out as opposed to back at Earth.
Well, I don't know why you're asking that question, but maybe you're from the GCHQ or something. But they were the telescope that was originally kind of the precursor to the Hubble telescope was a spy satellite looking at the Earth. But I'm not meant to tell you that.
Okay.
Anyway, so those are not my feet, but they're Claude's feet, I think. And I'm putting this person into the airlock to go outside and of the space shuttle and start doing a repair. And that's a view. It's quite a nice view because that's the visor of this.
That's amazing.
Yeah, up there. Of the helmet. You can see the Earth there. Are you seeing my cursor moving around?
Yeah, it's good.
Yeah. Okay, good. Yeah, so you can see it, and there's the cargo bay of the space shuttle. So it's kind of a nice picture.
That's an incredible picture, yeah.
The lights too. And so here we are going inside the telescope now, open the doors, and we weigh about 80 kilos, 100 kilos probably, together with the suit. The suit's pretty heavy, and if it was on Earth, now in space it's weightless, so we don't feel the weight, but it's still stiff, like I described, and massive. And that means if we move, it's kind of hard to slow ourselves down. Anyway, so you go in rather carefully into the doors of the telescope, and we start changing out the gyros. And this man, it's actually Steve Smith, I think. He has the gyroscope, and it's not very big, and there's 6 of them. And he's handing it into John Grunsfield, who's put his head in there. My job at this moment, when this picture was taken, was either to take this picture or to control them, basically to read out the instructions of what they were to do next. And then they would do the same thing for me and Claude Nicollier the next day. So there they are inside the telescope, changing out the gyroscopes. You see, there's a lot of stuff, a lot of tools. I had 100 tools. Each of them has a little tether, a little string attached to it, so that it doesn't float away. Because if it floated away inside here, it could, short something out, break something, or worse, get in the way of the mirror, damage it. Now, this is the next day. I'm up on the end of the arm. There are my feet in this little foot restraint here. And I'm holding, it's not your phone, but that is a 486 computer with a co-processor. And
wow.
and I got a lot of stuff on my tool stanchion here, and it kept bonking and floating and chinking into me. And I have to disconnect about 10 cables, each with 100 gold pins in it. I don't know if any of your watchers or students have repaired a PC before, but I was doing PC repair. Now, this is kind of the view you have. Wow. That's the view. It's not actually me. This is a friend of mine at University National Space Station. But the idea is the same. There's an arm right there. I do this thing. We're always tethering as close to the face. That's
Sorry, Mike, can you hear me?
Yeah, I can hear you.
Oh, sorry, we're just not quite hearing your audio over the video audio. So
maybe
you can talk us through it.
Video down, yeah.
Oh, there you go. There you go.
So, hold on. Yeah, the audio. It's funny. You wouldn't think there are sounds in space, but when he moves his hands around and he moves that hook around, you can actually hear it clunking through the spacesuit pressure.
Yeah, that's what I was wondering. And the kind of hissing noise. What's the hissing noise that we're picking up on?
That's the air, the oxygen moving into the. I've got to get onto the next slide, haven't I? Where are we? Next slide.
That's an incredible video, though.
So now that's me. Now, trying new things. One of the things I tried new rather late in my life was rock climbing, mountain climbing. I didn't really get into it's basically because I was the son of a Royal Air Force pilot, and we lived in nice exotic places in the Mediterranean like Malta and Cyprus, but never near mountains. So I never tried to climb a rock or a large mountain until I moved to Colorado. Well, actually, until I was at NASA. And this was really my first experience of being on the side of something that's a bit like climbing a mountain. Can you see that?
Yeah, it's unbelievable.
By the way, for those of you that are going to be astronauts, if you come to Earth and you see red dirt below you, and that's reddish, it's not Mars, it's Australia.
Oh, really?
Yeah, whenever you see red dirt, it's Australia.
Oh, wow. That's bizarre that you're so you climbing up there, but Earth's above you. It's kind of, that's a really weird sensation to feel. Yeah. Like everything's upside down, but you're still climbing up.
And then that's Claude Nicollier. He's the astronomer from Switzerland. And he's putting in this big box. You can't really see it very well here. that's going to go into the telescope. It's called the Fine Guidance Sensor, and it lets the telescope point better at the stars.
That's an incredible photo.
Yeah, they're saying hi. The solar rays of the Hubble there. So there's a lot of solar power in space. In fact, it's not 100% solar power. There is just a little bit of nuclear power for spaceships that go without humans to planets like Jupiter and Saturn and beyond. But for planets near the sun, they're called terrestrial planets because they're like the Earth. That's Mars, the asteroids, and Venus and Mercury and Earth, of course. They're called terrestrial planets by astronomers. All the spaceships and spacecraft that go to those use solar power because they're closer to the sun and the solar energy is abundant. That's a view of me taking part of the outside of the telescope off so I can get inside it. And,
what do you do with that piece while you're trying to work inside it? Just tether it on?
Correct. You tether it with one of those hooks that you saw in the video off of your stanchion, and it floats about and gets in your way. And if you knock it, it just bounces back at you. So you have to be very careful when you're doing your spacewalks.
Yeah,
so that's a view of the telescope out of our overhead window on the flight deck of the Space Shuttle. We've repaired it. We're letting it go, and we're very relieved. At least I am, that we didn't break it worse than we found it. Because, if you break the Hubble Space Telescope, that all the astronomers in the world think is the best telescope ever, and it probably cost $2 billion with all the missions to support it. If you actually were the one to break it, if I'd broken one of those gold pins of the computer, for example, that I was changing out with my inflated rubber gloves of the spacesuit, if I'd broken it, I would have been so miserable and ashamed. I think probably I'd have opened the little valve in the side of the helmet.
Don't say that. There would have been a lot of angry astronomers.
Yeah, that's right. So why come back to Earth if they're that angry at you?
Yeah, exactly.
Anyway,
yeah, you'd probably be safer to stay away.
We didn't break it. You can see now its little lid is open. That's where the light comes in. And the mirror is this telescope is a reflecting telescope. So some telescopes, binoculars, people will have come across, have lenses, glass lenses, but this telescope is glass absorbs some of the light. We talked about the atmosphere absorbing light from stars and from the sun. Because of that, if you want to see all the light that comes from the universe, you mustn't have any glass in the way. And so they just rely on all the light coming into the telescope and then hitting a mirror here and then going to detectors and instruments around about that level.
Wow. It's an incredible bit of kit, isn't it? Considering it's the size of a bus as well. That's unbelievable.
Yeah, it is. It really is. I think this is another video. So we're going to go stop share and go back to me.
Yeah, we'll come back to the next video. Let's get back to a few questions. We've had a few flying in. Okay, let's have a look. Have you ever had a power cut on the space station? If so, how scary was it? That's Charlie, age 7 from Kidderminster.
Well, Charlie, I'm one of the very few people in the world who've actually had a power cut in space, and it's pretty scary. It happened on the Russian space station Mir after the collision of a cargo ship with us. And to stop the air rushing out of the module that had been collided with, my colleague Sasha Lazutkin and I had to disconnect electric power cables out of the passageway so we could close the hatch and stop the air leaving the space station and stop it killing us. Well, we were successful in getting those cables out of the way, but we disconnected all the power of the space station and the batteries from the solar arrays that came through that hatchway. And the batteries of the station ran down in about 20 minutes. And then the space station was completely silent. Normally in space, like in a space station or in a space suit, you're always hearing a shh noise of fans moving air around, so that the carbon dioxide that you breathe out is absorbed by activated charcoal, lithium hydroxide, or that it supplies the oxygen to you. So get rid of hard carbon dioxide, supply you with oxygen. And those fans are critical. And so I was now on a space station without the fans running because there was no electric power. And the other thing about space is it's cold. The kind of background temperature of space is 3 degrees above absolute zero. Actually, it's 2.73 kelvins, but it's very, very, very cold, minus 273 Celsius. And that meant for us in the space station, as we had no power, and we're closer to space than we are to the Earth, if you see what I mean, we're getting really cold. And I could hear the space station creaking as it started to contract and get smaller, go ting, 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 as it was contracting, getting cold. Metal contracts when it gets cold. And I could feel the heat leaving my body going out through the window.
Oh, bet that was scary. That's a good question from Charlie. How did you get it back on quickly? I'm sure he wants to know that as well.
Well, it took us about 30 hours to do it, but we used our lifeboat spaceship called the Soyuz, and we fired its thrusters to put the space station in a spin. And we were able to move batteries around and get the space station to spin so that some other solar arrays that were not disconnected would point roughly to the sun.
That was clever. That was you were solving problems there, weren't you?
Yeah, I hadn't done that before either.
Yeah.
This is all about doing new things, right?
Yeah, and thinking outside the box.
You know what was hardest about that? It was persuading someone else to do something they'd never done before.
Yeah, and you had to do it.
I was the guest on that space station. I had to persuade the Russian commander to do that. And he'd never been trained on it. He had no permission to do it. He didn't know how to do it. And so I had to persuade him to do something that I had never done before either, which was to spin the station using the Soyuz lifeboat.
No, it's a good job you did.
Yeah, I guess so.
Okay, Hector aged 8 says, how many planets does Michael think there are in the universe?
I think there are probably, this is one of those like politician answers, but it's a grown-up answer. There are about 10 times more planets than there are stars in the universe. And there are, you know what 10 is? It's 1 with a 0 after it. And you know what 100 is? It's 1 with 2 zeros after it. I think this is probably like 10 with 40 zeros after it.
Really?
Yeah, a lot of them.
What would that be called?
I have no idea. I don't. That's why scientists don't use the word like billion and things like that and trillion. They use we call it standard index form. And a billion, which is 1 with 9 zeros, is 10 to the power 9, and you put the 9 above the 10. And that's how scientists refer to large numbers.
Oh, wow. Okay. So he hasn't got a clue to answer your question, really. No one. Yeah. One day we might know. Okay. What was the next question? Alfie wanted to know, I mean, this is kind of similar to going back to the power cut. I mean, you touched on it a bit there. How do you get electricity on the ISS? And that's from Alfie, aged 9.
I don't know if Alfie's seen any solar panels. I'm sure he's seen them from the train, maybe going through the countryside, or on some houses in housing developments. You'll see solar panels on the roof. We use exactly the same thing. And that picture behind me, let's move my finger there. Those are the solar arrays of the space station. So we use solar panels.
Okay. There you go. Solar panels. This is a really good, sorry, I got distracted because this is a really good question. Tom from Stockport would like to know, when was the last time you did something for the first time?
Well, I said it. I've never done Zoom before last week.
Yeah. So that was it. Last time our first Zoom call, when we did our Zoom call.
No. Actually, maybe I have once, but so there's always little things that you do for the first time, and there's lots of them. And then the big things, you only do those occasionally for the first time, right? And the big things are the things you remember. The last time I did a really big thing was probably, the Via Ferrata in Cumbria, in the Lake District. You have to go along on the outside of these sheer cliffs they have these metal staples into the rock, and you have to hook on and go to the next one, hook on and go there. It's just like doing a spacewalk, like climbing the Hubble Telescope. I hadn't done the Via Ferrata before. And
that sounds cool. What? How high are you then? Are you really high? How high are you?
I think it's probably 300 meters, 400 meters above the bottom that you could fall to.
Really?
There are a lot of people who just say no, not doing it.
Yeah.
If you're afraid of heights, that's a really good test.
Are you okay with heights generally?
Generally, yes.
Yeah. Okay. Scott Armstrong, what is it like to be weightless for the first time? Again, you touched a bit on that when you first got into space, but I mean, when you're flying around for the first time.
Your hands flew up, but you do feel like your tummy lifts a bit. You feel like your tummy kind of goes, you think you're not quite going to throw up, but you feel like there's a sort of, and then you realize it's not going anywhere. And if you're one of the lucky ones, you don't get sick, and you feel kind of lifted.
Kind of like when your mum and dad drives really fast over a humpback bridge. And you have that turn in your stomach, just and like that kind of happens, but kind of stays there a little bit.
Exactly. Or on a swing, actually. Or on a swing. Yeah. When you're swinging, when he comes up and then down, that moment there is weightless.
Okay. That's a good way of describing it. Okay. Millie, age 10 in Scotland, says, does the visor protect your eyes from the sun?
Absolutely, Millie. It's essential. The sun's rays are much stronger in space than on Earth. The atmosphere, we talked about it absorbing some colors, and it also absorbs ultraviolet, which is what gives us sunburns. And in space, the ultraviolet from the sun is really strong. Without that visor, I would get a red, bright, burned face in 30 seconds.
Is it easy so you have kind of different lenses often?
We actually have three. We have two clear ones, and we have two because it's for safety in case one cracks.
Mm-hmm.
So we have two clear ones, and they're made of plastic. Then we have the gold one on the outside.
Okay. And the gold one is for heavy sun.
Yes.
Okay. All right. What was your first thought while on Mir when it depressurized? Did training kick in immediately, or were you scared? Aaron, age 10. That's a big question from Aaron.
I was scared for about 10 seconds, thinking maybe this is when I'm going to die. I just thought that. And I sort of was waiting for it. And I was waiting for the air to rush out of my lungs, but it didn't happen. And then I said to myself, things are looking up. And then I felt my ears popping, and then I thought, oh, not so fast.
Oh, wow.
And I realized with my ears popping, it must be because there's a leak. It just wasn't rushing out so fast. And so then I thought, well, maybe we're going to die, but not quickly.
Wow. And then you thought, let's get to work and fix it.
Training and trying to solve the problem started to kick in.
That's good. It's good. That's a good it's a good test of your instincts that you could still get to work even when there's deep down fear in there. That's good. How big is the solar system? How is it measured? That's Aidan, aged 8.
Oh my, Aidan. The distance to the sun from the Earth is about 93 million miles. And we call that, or ancient astronomers called that, the astronomical unit. It's what a meter is. It's a measure of distance. So the astronomical measure of distance is the astronomical unit. We call them AUs. And the solar system is very roughly 100 astronomical units, or in radius. So 100 times the distance from the Earth to the sun.
Wow.
If you include all of the kind of the small icy blobby bits that are beyond Pluto.
That's incredible. That was a good answer. I had no idea about that. Okay, let's do one more quick question, then we'll check out another video, Mike. How about that? Yeah.
Sure. Yeah.
All right, let's have a look. We've done okay. How many sunsets and sunrises do you get to see a day on the ISS? That's from Thomas Sidebottom.
16. So we orbit and that's because we go around the Earth every hour and a half. If you take 1.5 hours or an hour and a half and you divide it into 24 hours, you get 16. So we go around the Earth 16 times in 24 hours. And of course, we go onto the dark side of the Earth for a little bit of time, and then we go onto the bright side of the Earth. And because we just do that once every hour and a half, we see a sunset 16 times, and we see a sunrise 16 times in 24 hours.
Amazing. All right. Well, on that note, should we have a little bit of spacewalking? Got a bit of a video of some spacewalking and some views from space?
Yeah, hold on a sec here. I just didn't share my screen, did I? Didn't share my screen.
Did you jump the gun a little bit? Yeah. Share screen first.
Yeah, I'm trying Zoom for maybe the third time.
You're getting better every time, though, Mike.
Thanks, Gandalf.
You're better than me. I can't do PowerPoints. You've learned more about it than I have, so I feel comfortable with you in control.
There he goes. So now we run it. Excuse me. So this is a little video of the Hubble. That's the Hubble Telescope. And we're going to see some scenes of what the Hubble looks at. So that was us working on the telescope, opened out. Now these are the pictures that the Hubble has taken. And they come back to Earth by radio, a bit like cell towers, coming to your phone. And that was a supernova. This is a nebula called the Horsehead in our galaxy. There are billions and billions of galaxies, but Hubble, the closer things are, the more detail Hubble can see. This is a picture from some of the mission that I was on repairing the Hubble. There's that instrument called the Fine Guidance Sensor. It's about the size of a baby piano. And it helps this telescope to point better at the stars. These are still shot. Now these are pictures of nebula. This kind of cloudy stuff that you're seeing, but with definite edges, these are called nebulae, and they are the result of a star exploding, compressing gas. And there's a lot of rock and metals and things in that exploded supernova, and they coalesce to form new stars. So out of the old stars, this is a picture of a galaxy. Every single white bit in these pictures, or red or colored bit, is a star. That's why I said there are so many stars in the universe. You'd probably take a 10 and put 40 zeros after it. And each of those little ellipses are galaxies. And now we're going to see how galaxies come together. Galaxies are made up of stars, about 100 billion stars, and they have gravitational attraction for each other. And so sometimes galaxies will drift at speed over 1 billion years towards each other like this. And then the stars within them will act gravitationally on each other and then cause these extraordinary shapes that Hubble has seen and actually measured. Wow. So what you saw there were simulations of what Hubble has actually been observing. This is the edge of a galaxy. And now we're looking at the edge onto it. And you've seen the dark black bits, those are the dust clouds. And within those dust clouds, we can't see much, but we know stars are actually forming, young stars. They're only a few million years old, tens of millions of years. This is a galaxy with 100 billion stars in it. I think it was Andromeda. I think this is Messier 31. Anyway, these are all galaxies with different colors. The colors are coming from not only the stars, but the ultraviolet radiation exciting and refracting through the dust clouds around them. Often when you see reddish colors in these images, it's coming from hydrogen. The universe is mostly made up of hydrogen. And the other major part of the universe is deuterium, which is another type of hydrogen. It's called an isotope of hydrogen. And those are the two basic constituents of the beginning of the universe. And then those hydrogen atoms and deuterium atoms came together in the stars to make all of the chemical elements that we know of in chemistry lessons, and we see around us on Earth and on the planets. So out of the hydrogen comes everything else. However, these images, even though they're showing such amazing stuff in the universe, it's almost as if the universe is full of stuff. Actually, the space between stars is huge, which is why interstellar spaceships are a long, long, long way off in our future. Because between stars, you'll sometimes get to bits of space where there's only 1 or 2 atoms of hydrogen in a cubic meter. However, even though Hubble has seen all of these images and all of this matter in space, it's also told us a story about the universe that's even more amazing. And that is, we're only seeing 1% of all the matter in the universe.
Wow.
I'm going to get out of this show here.
That was an amazing video. You just kind of get a bit sucked into that video, don't you?
Don't you? Yeah.
Beautiful. All right. If you stop sharing, we've got quite a few questions to try and fly through. Okay. This one follows on from that quite well. What's inside a black hole? And that's Maddie, age 13.
Maddie, we don't really. We know there's some. We know one thing that's inside a black hole, and it's called matter. But that's a bit like a grown-up giving you a vague answer. We don't know what type of matter. We don't know. We don't know what if it has color. We don't know if it has charge. Well, we do know it has charge. We do know that, but we don't know anything else about it, because one of the laws of physics, and it's a really fun subject to study, is that when a black hole is created and matter rushes in, it rushes in and time slows down as it rushes in. So we will never see a black hole finish being created. Never, ever. Only in our infinite future will we see the black hole actually finish. But for you falling into the black hole, you will just fall straight in. Now you will get elongated and stretched so that all your atoms get pulled apart. Not a good thing. So no one will live in it. What's left in the infinite future for us in the black hole is just matter. It's just the inertia, the inertia of things that you want to move around, and the charge.
Okay. All right. I cannot believe how fast this hour's gone. I'm going to try and get through these questions as quick as we can. So, right. Freya, age 7, said, why are there different shapes of rockets?
The rockets are basically tall, right? Although some are fatter. Yeah, I have to acknowledge that. They're long and thin because the Earth's gravity is actually quite strong compared to other planets and bodies in the solar system. And to get away from it, we have to keep throwing matter out of the back of our rocket to go up. And we run out of, it's better to throw away your fuel tanks as you do that. So we do what's called rocket staging. So we make rockets out of a number of mini rockets on top of each other. And that's why they end up being tall and pointy. Some rockets have much more efficient engines, and they can do it all at once and be more squat and conical. And maybe future rockets will be more like that because they have more powerful engines and ways of getting that fuel out quickly.
Okay. All right. Keeping on the rockets, what is the highest speed a rocket can get up to? That's from Miles, age 9, in Holmes Chapel.
I think the record so far was Galileo going to Jupiter. It was about 100,000 miles per hour.
Wow.
Normally, when we go into space on the Space Shuttle, we go at 17,000 miles per hour. 17,000 miles per hour. When we go, the space station is going around the Earth at 17,000 miles per hour. So the record, I think, is about 130, maybe 130,000 miles per hour.
Okay. Alex, aged 11, said, how heavy is a spacesuit?
Spacesuit's about, it's 80 kilos. It's pretty ridiculously heavy.
Okay.
It's just as well we don't have to, when I wear it on Earth, and I've had to do that a couple of times without being in the swimming pool.
Yeah.
If I go over on my back, I can't get up.
Really?
They have to, two or three people grab my hands and pull me up.
It's like being in those toy sumo suits when you have like fairgrounds and stuff. You can't get up with them either. Okay. Do meteor showers have any effect on the space station or satellites? That's Aaron, age 10.
Yes, absolutely, Aaron. Meteor showers are actually quite scary. They're beautiful. When I was looking down at the Earth, I saw meteors going into the Earth's atmosphere, making shooting stars. And then as I was looking out of the window, this is on the mirror, it goes ting. And a meteorite hit the window.
No way.
A tiny fleck, a tiny thing, a grain of sand. So it didn't break the window, but it scared me. And when you look around the space station, the International Space Station, ISS, you'll see holes as big as your fist in the solar rays from space debris and space junk.
Wow. Okay, Freddie, aged 8.5, wants to know, will there be any more space stations built around the Earth? We really enjoy seeing the ISS.
Yeah, I think the ISS will be there at least until 2030, so 10 years from now. I think most likely it'll be boosted one day to a higher orbit and become like a tourist space station destination. It'll be dangerous to go there for long because of the radiation. But I hope it will be boosted, not deorbited into the Pacific. And after that, there'll be other space stations, probably space hotels is what I'm thinking, and space fabrication facilities where one of the big advantages of being in space is that it's weightless. And it means you can grow biological forms, organs in space without errors. Whereas if you do them on Earth, because gravity is always making your Petri dish kind of hold down, or sludge, you could imagine, and people want to do this, scientists are trying to do this on the ISS, you could grow eyes, lungs, hearts, kidneys. So if we get sick on Earth, we might be able to apply for or buy an organ that was grown in space at a space factory. So those will be space stations in the future.
Wow, that's incredible. Okay, one last very quick question. Elsie, age 6, would like to know what it's like looking back at Earth from space for the first time.
It's emotional. You feel a lot of love for the Earth. You see how the Earth is really beautiful. I think we like blue. I like blue, the blue color. And so a tear will come to your eye as you think about the people that you love, your family, the people who wished you well when you were launched into space. And that's the feeling I had.
Wonderful. Have you got any final messages, Mike, before we sign off today? Anything to all the budding physicists or scientists or astronauts out there watching?
Science is amazingly rewarding for you. If you like stories and you like watching movies, yes, that helps motivate you to do something. But something that keeps you really interested and fascinated for all of your life is science. And if you have any curiosity about where we came from or how the universe was begun, why things move the way they do, why rockets are shaped the way they are, why airplanes travel the way they do, how, if you look at the clouds and you see how they're turning over, if you're looking at rivers and how the water flows over boulders, all those things that are ordinarily just beautiful to look at, there's behind it even more beauty. It's the science of what makes it happen. And studying science in school is really a worthwhile thing, I think, for you emotionally, and it's a very rewarding thing. It's fulfilling.
Wonderful. All right. Well, Mike, we'll let you go. We'll let you go have a real breakfast. We know it's early in America, so you can go and start your day properly. But thanks so much for your time. It's been an absolute honor to talk to you.
Thank you. And so I now click and say goodbye, don't I?
Yeah, you say goodbye and then just sign out, man. That's all you got to do.
Bye, everybody. Good luck.
Cheers, Mike. See ya.
Cheers.
There you go. That was Mike. Absolutely fantastic. Thank you again, Mike. And thank you for your questions. If you enjoyed that, we'll be back again same time next week for another Space to Learn. Some other exciting things coming your way. Tomorrow at 2 p.m, our friends at Minerva Tutors are going to be teaching you how to make your own body armor. That sounds quite interesting. Head over to minervatutors.co.uk to get involved in that. Mum and Dad, we'd like to see you again on Thursday for more space talking with an astronaut. This week, we're going to be joined by astronaut Greg Johnson. Find out all the details for that at ISSET.org. So apart from that, all you got to do is hit subscribe on the YouTube channel so you don't miss any of the Space to Learn shows and all the other content. There's so many good other clips on there, so check that out as well on our channel. And also follow us on Twitter and Instagram at ISET_STEM for all the other information. On that note, I'm off. Thank you so much for joining us. Stay safe. This is Adam Gendel, spacing out. Spacing out. Spacing out.